The moment you sit down, they charge you a fee. They just do. As soon as you get in the car, you have to pay. So let's say that fee is going to be $3. And then, once they start moving, they charge you money per mile. Okay? Have any of you ever ridden in a taxi?
Nope.
Okay. So they charge you like a $3 fee, and then let's say $2.50 for every mile. It's usually not that easy of a formula, but we're gonna make it an easy formula. So if you drive less than a mile, if you drive, like if you get in the car and you sit there for a minute and you're like, oh, crap, I forgot, whatever, no miles are driven, you owe them $3, okay? If you drive no miles, if you drive 1 mile, how much do you owe them? $5.50. If you drive 2 miles, how much money do you owe them? $8. 3 miles? And let's go with 4 and we'll stop. Right. Okay.
So even if you go like 1 mile, you have to pay them.
Yeah.
Just $3.
Actually, well, we'll talk about that later. Okay. So, this 250 right here, that's the rate of change. That's how much this is changing every time. Okay? And on this particular problem, the rate of change is constant. It's always 250. That rate of change always being 250, that constant rate of change, makes this a linear function. If I were to graph this, it would be a line. It would start at 3, and for the first mile, it would go up 250. And for the second mile, it would go up 250 more. And the third mile, it would go up another 250. So that if I were to connect all the points, it would be a straight line. What would happen if you only went half a mile? Then it would be $1.25. So, the constant rate of change makes it a linear function, okay? Linear function is just, a linear function, really it's just a function whose graph produces a line. Let's try to look at. And that's whose, not who is. Whose graph produces a line. What makes it produce that line? X is only to a power of 1 right here. This M, does anybody remember what that M is called? It's the rate of change, but what else do we call it? Slope. Yep. If M is positive, which way does what does the line look like?
It's going up right.
Yep, that's if M is greater than 0. What if it's negative?
It's going
Down. Yep. If it's less than 0. Exactly. Good. Alright. Now, as Let's take it real. Do you remember the slope formula? Can I move this? Alright, it's the change in the output over the change in the input. A fancy way of saying that is delta y over delta x, but what you're used to seeing is y2 minus y1 over x2 minus x1.
Yeah, I like that one, but it's
Alright, delta means change. So anytime you see a delta in math, you're finding a difference. That's a delta x, delta y, delta whatever, that means you're just finding a difference. You may even see it written like this. Because what does f of x mean? Y. F of x and y are the same thing. So you may see it written like that. Alright, let me find the slope. You have all that written? Okay, so the population of a city increased from 23,400 to 27,800 between 2002 and 2006. Find the rate of change for the population during that time. Which one's the input and which one's the output?
the output's the population.
Okay, so it's going to be the change in population over the change in years. Okay, maybe I can write the y, I don't know, in years, right? Okay, generally your years time, passing time, is going to be your independent, your input. You can't change time. Time may change me, but I can't change time. So 27,800 minus 23,400 from 2006 to 2002, right? 44 over 4, 1,100 people per year. That's our change. We were to graph this, and that would be our slope right there. Right? Okay, now let me give you pretty much the same problem, just a different look. F of 3 is negative 2. F of 8 is 1. Find the rate of change. Okay. What's the input? What's the output? What's going to be on top?
The 8.
The what?
Negative 3, right?
No.
No, 1 negative 2.
Remember, this is f of x equals negative 2.
Oh, okay.
So the 3 is the x, and the 8 is the x.
Yeah.
So 1 minus negative 2 on top, 8 minus 3 on bottom. So what is that, 3/5? 3/5. Okay. Is this increasing or decreasing?
Positive.
Positive, so it's increasing, right? If it were negative, it would be decreasing. Yeah. Okay. So here's what you need to know from today. We're going to stop because we did a lot of housekeeping with the Google classroom, and we have more housekeeping because you've got to get signed in to that Khan Academy. But we talked about a linear function, we talked about increasing and decreasing, and we talked about slope. You probably need to practice finding slope in just given the numbers like this, big time, given the numbers like this to be the practice, and in a situation like a salesman sold this many t-shirts. Okay? In your book on page 117, well, it's PDF 117. It's the book page is page 107. That's where it starts talking about slope. Those are some really good exercises to look at and to practice. Okay, really good. It's going to go into, here's the slope, write the equation, and we're not going to talk about that today. We will talk about that, but not today. Okay? So we're going to stop there. Definitely